Wired and wireless networks. In this lesson, we're going to look at common issues that arise with wired and wireless networks and common troubleshooting steps that you can take to rectify these situations. So let's go ahead and get started. Intermittent wireless connectivity. When you have a wireless signal that is intermittent, the most common two problems are a lack of a good signal and interference. Increasing the number of wireless access points for coverage or moving closer to them to the access points can address the lack of a good signal. Interference can be addressed by reducing the number of devices competing on that same channel. In many instances, however, the interference may be coming from external sources like microwave ovens and cordless phones and other devices that's using that same frequency band. Now, to avoid common interference, what you want to do is look at a different band. Say, for instance, if you're using 2.4 gigahertz, you may want to switch to 5 gigahertz band. Using the 5 gigahertz won't guarantee you an interference free connection, but it will provide a better connection that than the band that's being used by 2.4. If that band is saturated as well, and there's a lot of devices on that, you can try the new 6 gigahertz band, which is the Wi Fi 6, which was ratified in July 2020. However, in any event, basically what you're doing is trying to find a free channel that you can use so it won't be as much interference from other devices. External interferences. Now, we talked about external interference just briefly. Other things that you can look to as far as causing interference would be, of course, the microwaves and cordless phones. However, in bigger and larger environments and corporations and industrial plants, large motors or generators can cause interference. Also, fluorescent lights can cause interference. So you want to be constantly checking your surrounding area to making sure that you're not on the same channel or using the same band frequency that other devices would be using. To do that, you want to perform what's called a site survey. A site survey is peering into the radio spectrum to see what channels are crowded and which channels are not crowded. A lot of the wireless devices now have built-in utilities that you can do a site survey with. What you're looking for is something called a signal to noise ratio, or the SNR. And basically, what the signal to noise ratio is the desired signal against the background noise. Slow network speeds. With slow network speeds, first thing you want to do is check the network traffic. There's a lot of things going on your network that could be generating traffic and causing your traffic to be slow. Just like traffic on a highway, the more cars you get and the more traffic you have, the slower the traffic is going to be coming. Same thing on a wired and wireless network. Interference could be one of the biggest factors of that. Reducing devices that's on the same channel, that'll reduce that a lot of that traffic and thus increase the network speeds. Again, look at the channels that you're using or the frequencies you're using. 5 gigahertz versus 2.4. A move to 6 gigahertz is an option. Latency on the network as well is a problem, and we'll talk about latency a little bit more in detail. And also excessive network broadcast. When devices are on a network, they constantly communicate, trying to find IP addresses, trying to find the router. And this is like a network chatter. The more devices that you have on there, the more network broadcast that you have, thus reducing the network speeds. Limited or no connectivity. Now, there are times when on your device or laptop or desktop, you'll see a sign pop up that says limited or no connectivity or limited network access. Bottom line, what your system is trying to tell you is that it cannot access the internet. It cannot access the network. So, a couple of things that you can do to check that is number one is possibly there's an IP address problem. If you are getting an IP address from a DHCP server for whatever reason, that DHCP server is not responding, or when it refresh, you're not getting a new IP address. You're getting what's called an APIPA, APIPA, local connection, no internet address. What you need to do is refresh your IP address. Check the DHCP server. Is it the DHCP server that went down, or is it your system not um, getting an IP address from that DHCP server? Once you get this resolved, Test to see if you can get out to the network. Test to see if you can get out to the internet. Ping something out on the internet using the ping utility. You can ping the IP address of 8.8.8.8 or a server, www.google.com, to see if you're resolving pings that way. Jitter. Jitter is a variable of latency, which is really a drop packets. Now, VoIP calls are delicate and they're not very good with drop packets. They have to have a real time streaming going on. And when you have these drop packets, you have a choppy phone call. That is that jitter. It makes the calls almost unintelligible. You really can't hear what's going on. So, again, that's that jitter. Now, along those same lines, and a bigger component is poor voice over internet protocol or VoIP quality. So that's basically your poor VoIP service overall. And there's a lot of things that comprise of this. Jitter, what we just talked about, a big component of that is latency. Latency is those drop packets, high network traffic, low bandwidth, all those contribute to latency, high latency. And latency is that space in between those packets traveling. When the stream of packets need to be a constant. When you have high latency, those packets are being dropped. Check your network equipment. This could be a problem with the network equipment. It could be your firewalls or your switches. Check the network traffic and the devices on the network. Again, this all goes in line what we were just speaking about. When there's high and heavy network on the traffic, it'll give an overall poor quality for your VoIP traffic. One thing you may want to do in a situation like this is implement what's called quality of service or QoS. QoS is a service that prioritizes the VoIP traffic and makes it at a higher priority. Port flapping. When a switch port opens and closes rapidly, this is called port flapping. And there's a lot of things that can contribute to port flapping. It could be bad cabling, a duplex mismatch. It could be a in device like a server or a computer that's constantly rebooting. It could be again bad switch ports. Those are the things that contribute and also cause port flapping. So again, endpoint issues, reboots, and sometimes when a device goes into power save mode, you want to check the cabling, see if it's a cabling issue or a hardware issue. Check your switches. It could be a configuration setting, but these are the things that contribute to port flapping. And we've talked about latency. Let's talk about high latency and dig in as far as what does that really mean. Basically, high latency is the delay of a data transfer. When those packets are being sent, any type of delay is latency. High latency is excessive packet delay. Now, if you were moving a big data file and you were moving it from server A to server B, as that file is moving, some packets may get dropped. TCP, that which we learned earlier, will retransmit that and correct itself. However, if you have a real time media like VoIP or a video call, it cannot tolerate a lot of latency. So therefore, that's when you have the freezing still images or the jitter on your phone call. So high latency is the culprit of that. So again, when you do have high latency, check the network traffic, do a packet analysis, find out what's on your network that's causing the high latency. You want to do a network assessment. So those were the common areas that you would look for when you're troubleshooting wired and wireless networks. We talked about and covered the intermittent wireless connectivity, slow network speeds, limited connectivity. We talked about jitter, poor voice over internet protocol or VoIP quality, port flapping, high latency, and external interference. Thank you for joining me in this lesson, and I will see you in the next lesson.